2, 1.
Hi everyone, and welcome to our third webinar of a three-part series for the ASEAN Fall Army Worm Action Plan Biocontrol series in collaboration with CABI. We'll be starting in around 1 minute. We're just going to let everyone join us and give them that time. So if you want to know how to interact today, which is very important and we encourage that, have a look at the slide in front of you. The main way of interacting will be using the Q&A box. So if you have any questions for any of our speakers, and we really encourage that, please use that Q&A box. Use the chat if you just want to give us a message, if you want to share a link, if you want to highlight an important point, you want to congratulate one of the speakers, please feel free and do that in the chat. If you really want to say something, you can raise your hand, and you'll see under 5 there how to raise your hand. And if you could rename yourself, that would be really useful too, putting your name and your organisation. But don't worry too much if you don't get around to doing that, but have a good look at that. And just while you're here, I'll just give you a quick look at the agenda. It's a really full agenda today, so it's quite exciting. And all our speakers are ready to go, so you'll see them on the video now waiting. So we've got 137, and actually quite a few people are still joining. We had over 500 people register for this webinar, so that's outstanding. We normally expect about half of the people to turn up, so there'll still be a lot of people today joining us. And as you can see, this is webinar 3. It's the last of a 3-part series. We are looking at holding some technical workshop sessions in November, so we'll get in touch with you about that soon. And I just wanted to highlight here, and Roger will be very happy from CABI here, but I think this is really important. There is a research collaboration portal that CABI have put up, and we really are encouraging people who are doing research in this area to share their research, and you'll hear from others who are maybe working in the same area, but it will help grow the network. So I encourage you to do that. And we should be starting soon. I'll just hear from Pranav, our technical expert who is online and supporting us today. Pranav's going to give me a countdown, so we're really lucky. We're going to have a countdown to recording, although I think recording might already be on. I'm not sure. Pranav?
Yeah, it is. Alison, go for it.
Well, there we go. Shall we start? How many people do we have online?
156 at the moment. Okay.
Well, I think we better get started because we have got a really busy agenda. So welcome everyone to this third webinar of a 3-part series. It's a pleasure to have you join us. I am Alison Watson, and I'll be your moderator today. Please make yourself familiar with the platform here and how to use it. If you have any questions, as I said, if you were with me before, use the Q&A box to ask your questions to the speakers. And just use chat for general chat, making a comment, thanking a speaker, sharing a highlight. And if you really want to say something today, you can also raise your hand. As you can see, we have a very full agenda. All our speakers are on video at the moment, so they are all ready to go. It's going to be a very action-packed agenda. We're going to try a video halfway through. We're going to see how that goes, but we're hoping it's running perfect because it's quite a interesting video with great pictures that I'm sure you're going to enjoy. And what we do normally with all our webinars is we sort of get to know who you are. So I'm going to get Pranav to run a poll. Hopefully this works. And what I want you to do is choose what best describes the organisation or sector you work for. And I'll give you about 20 seconds to choose that. Choose the best choice for yourself. Just to make it a bit different this time, you'll see that I've added a couple more choices. So if you've been with us from series 1, from part 1, I've tried to diversify the choice a little bit. And we might stop that soon. Pranav, how many people we got? There we go. Wow, we've got 32% from government, so that's actually excellent to see. Nice to see that sector very strongly represented. Private sector 18 and research 24 and 15 international organisations. Okay, that's very interesting. So thank you for joining us. It's nice to see that mix of people, and we've still got a lot of people coming in, so I'm sure that would actually change by the end of the session. But yes, thank you very much for joining us for those who have just come in. Okay, so next page, I'm going to move the, here we go. I'm going to move to our first introduction, and this is Graham Dixie, who's the Executive Director of Grow Asia. Welcome, Graham.
Thank you, Alison, and welcome everyone. It's a privilege to say hello to you all and to thank you for attending. We've had sort of, I can see the numbers rising up at the bottom here, but this is the fourth in the series of webinars, all of which I've attended, and we got the numbers just now that something like 1,200 people have registered for these webinars, and at least 800 have actually attended. And I have to say that I found them really interesting. And one of the things that has struck me about it is the depth of knowledge that we're picking out in the region, that we are having discussions on the size of granules or the flight path of a drone, some really very, very detailed conversations. And obviously, I think what we're picking up is the depth of knowledge in the region is far greater than we'd initially anticipated. But I think what these webinars are doing is something else, is knitting together those different people. And what we're seeing is some very interesting spillover effects where people are contacting one another, starting in talking about ways that they can work together, which is exactly what we wanted. But it's also building a broader body of knowledge, so that rather than us knowing individually a lot about a very small area, that we're being able to link that into the bigger storyline of what's going on globally, what's going on in the region, and what are the issues coming up in the fall. So I look forward to today's program, and I pass it back to you, Alison. Thank you.
Thank you, Graham, for the introduction. And now I'd like to introduce Roger Day from CABI.
Thanks, Alison, and thank you, Graham, too. CABI is very pleased to be co-hosting this next webinar in the biocontrol series with Croatia. It's been an excellent series so far, and today is going to maybe even top the ones we've had already. Biocontrol is central to the IPM of Fall Army Worm. I think we all know that. The challenge is to get it put into practice, and getting biocontrol central to IPM is a challenge that I know we all face, and our speakers today are experts in that, so I'm very much looking forward to what they've got to say. The challenge is not only getting a method which works, it's getting it put into practice, and put into practice cost effectively. And that's the challenge I think we face. So we look forward with interest to what our excellent speakers have to say. So welcome.
Thank you very much, Roger. And it's been a pleasure for Grow Asia to work with CABI as well. And I'd just like to welcome again all those government people across ASEAN countries. It's great to have you on board, and particularly the members of the Expert Working Group on Phytosanitary Measures who are part of the task force. But it's great to see 191 people on board already into this webinar. So without further ado, I'm going to stop my video. And then I'm going to move to our next slide, where I'm going to introduce our first speaker, Chris and Graham and co. You can turn your videos off if you would like, and we'll just leave Dr. Rangaswamy Muniappan, and Muni for short. He is the director of the IPM Innovation Lab at Virginia Tech. Muni is an entomologist who has specialized in biological control and integrated pest management research in the tropics for more than 35 years. As program director for the IPM Innovation Lab, Muni works with USAID and project partner institutions across the world, particularly in Asia, Africa, Eastern Europe, obviously Caribbean and the Latin American countries, and in Vietnam and Cambodia in Southeast Asia. Muni, welcome.
Thank you, Alison, and thank you, Graham, and also Roger. And I will start my presentation on the augmentation and biological control of fall army worm, potential for ASEAN. Of course, there are quite a few slides will show some work that we have been carrying out in East Africa as well as in the South Asia region. Next slide, please. Okay. Biological control, as you all know, it has three categories: classical, augmentation, and conservation biological control. In the classical biological control, we introduce the natural enemies from the pest native range into the new area where the native natural enemies do not provide control. We had very good control of papaya mealybug in Asia by introducing a parasite from Mexico. That's a classical example. Recently, work was done on controlling cassava mealybug in Southeast Asia. Chris and his colleagues did that work. So that is under classical biological control. Augmentative biological control is periodic release of natural enemies. It also includes release of or spraying with the biopesticides, all those things that we repeatedly use in the field in a season we call as augmentative biological control. It's like treating the seeds with trichoderma. It is a beneficial fungus, and planting it, that is one of the augmentative biological control cases. We also release of trichogramma, the egg parasite, for controlling different caterpillar pests that also come under augmentative biological control. Conservation biological control, of course, it is conserving the existing natural enemies in the system, and quite often it is done by reducing the chemical pesticide in the field. Next one, please. Okay, under augmentative biological control, we have inoculative as well as inundative. In the inoculative biological control, we just introduce the natural enemy in the early stage once, and it multiplies and takes care of the pest in the field or in the greenhouse, like releasing the predaceous mites for controlling the spider mites in the greenhouses, or seed treatment with trichoderma once, and it takes care of the soil fungal problems by multiplying in the field. And in the inundative biological control, we have to keep releasing periodically so that the natural enemies will stay in the field and take care of the pests. The same thing in the case of multiple spraying with the biopesticides. Here I have given an example of using the fungus for controlling the locusts. Even for controlling some of the caterpillar pests, we use inundative release of trichogramma. And there are several examples. Next one, please. Well, whenever a new pest or a exotic pest gets introduced into a new area, in the first 1 or 2 years, the population goes up, and then the population will come down because the local natural enemies catch up with that population. It may come down, and it may not come down below the economic injury level. In that case, we have to introduce some of the interventions, either using chemical pesticide or biological control, or different options we have to take so that we can bring that population below the economic threshold level. Hopefully, like using classical biological control or augmentative biological control, we can bring that population below this level. So that is what we are aiming with the fall army worm. Next one, please. Well, this slide was prepared about a year ago, so I tried to collect the data. So you can see in the center of origin of the fall army worm, that is the Americas, they have identified several natural enemies. Larval parasites alone about 150, larval natural enemies about 150. But in Africa, in the last 3 years, they've found about 4 natural enemies. I think this year there are more have been identified in that region. In India, for example, within a year of fall army worm introduction, they found these many natural enemies, and still they are finding more natural enemies occurring in India on fall army worm. Next one, please. Well, some of the agents that are being bred, or at least being attempted to be bred in the laboratory and to be released in the field, are Trichogramma prettiosum in South America and also in India. Then Trichogramma wangi. Recently we found it in Tanzania and Kenya. It seems to be a very good parasite, giving good parasitism against the fall army worm. And we are producing it in Tanzania and Kenya now. Trichogramma chylonis, it has been found in different parts of Asia and Africa. That is also being reared in the laboratories. Trichogramma virilia, that is being reared and used in South America. Of course, Telnomus remus, it is a very popular parasite, and I will talk about it later in the next slide. And it is being reared in Asia as well as in Africa for augmentative release. There are also larval parasites like Brocan brevicornis that is being reared in India, and Brocan hebitar, it occurs all over the world. It is being used for controlling different caterpillar pests. And currently it is being reared in Senegal, Niger, India, Bangladesh for controlling caterpillar pests. Hopefully it will be used against fall army worm pretty shortly. Also in the Philippines, they are using a predator that is the earwig for controlling fall army worm. Next one, please. Well, fall army worm eggs are covered by scales or hairs. You know, the egg mass is covered by that. It interferes with the efficacy of some of the parasites, especially Trichogramma. Next one, please. Trichogramma species, some of them find it difficult to go through the scales and parasitize. This work was done in Niger. As you see here in this slide, the Telnomus remus was able to parasitize the eggs with the scales and without scales. But the Trichogramma with the scale had difficulty in parasitizing. But when the scales were removed, the parasitism went up almost doubled. Next one, please. This work was done in Kenya, and Dr. Tadali Tefra was doing, and they were releasing Trichogramma chylonis in the field, and they were finding the reduction in egg masses and the reduction in larval stages wherever they release the egg parasites. Next one, please. Well, this slide shows the origin of the Telnomus remus. Telnomus remus was first found in Malaysia in 1935, and then Dr. V.P. Rao from India went to Papua New Guinea and picked it up and introduced to India in around 1965. From there, he shipped it to Israel and then to Caribbean countries. From the Caribbean countries, it was introduced into South America, then eventually to Florida. And now it has been found occurring in different parts of Africa. Probably it migrated or moved from Israel into African countries. And also similarly, we are also finding this parasite in different South and Southeast Asian countries. I'm sure if the surveys were conducted in other countries, we will find this parasite occurring naturally over there. Next one, please. This slide simply shows the introduction of this parasite, Telnomus remus, from Papua New Guinea to different parts of the world. Okay, I won't go into reading this slide, but you can get it from Alison and her colleagues. Next one, please. You can see here Telnomus remus. It is a very effective parasite. It is able to go through the egg masses of the Spodoprota frugivora or the fall army worm and give good parasitism. And Trichogramma, some species of Trichogramma are more effective than the others, like Trichogramma proteosum or wangi are more effective than the other species. So some of this mass production of the parasites are going on in Niger, Kenya, Tanzania, Nepal, Bangladesh, India, and also some limited field releases have been made in Kenya, Niger, Tanzania, and in India. And this work was started almost in 2019, but since the coronavirus pandemic started early in 2020, this work has kind of got delayed in many of these countries. Next one, please. Okay, you can see here, field releasing Telnomus remus from the laboratory culture, you can almost increase the parasitism up to 60% in the field. Without that, we get only about 10%. Next one, please. Similarly, in some of the laboratories in India, they are working on the larval parasite. They found this Brocan brevicornis attacking the 4th and 5th instar larvae of the fall army worm. The egg parasites take care of the the eggs of the fall army worm. The 1st and 2nd instar usually gregarious and they stay on the leaves, and then the 3rd, when the fall army worm reaches the 3rd instar, it becomes cannibalistic and they will eat each other. Finally, you will find one big worm in the world that may be around in the 4th or 5th instar stage. So this Brocan brevicornis specializes in parasitizing 4th, 5th instar larvae of fall army worm and other caterpillars too. So we could combine the egg and larval parasite in the field to get more effective control of the fall army worm. Next one, please. This slide also shows about the releasing the Brocan brevicornis in the field. We can increase the parasitism as well as control the larvae of fall army worm. Next one, please. This is Hebrobrocan habitat, Brocan habitat. Currently it is used for controlling the pearl millet head miner in Niger. It is a polyphagous one. It will also attack the fall army worm. Next one, please. In Niger, what they do, they rear this parasite in the laboratory using the rice meal moth caterpillars. And they have developed a technique. They produce small gunny sacks and that put about 200 grams of the grains, broken grains of maize, sorghum, or wheat. And then they place about 20 to 25 rice meal moth caterpillars and also release 2 mated females of the Hebrobrocan habitat inside these sacks. And then next one, please. They would tie these sacks in the field. Here you can see they have used a bucket to protect the sacks from the rain. Here they have used a shell of a goat to protect it. And sometimes they even tie it on the top of the granaries so that these parasites will be coming out of this sack and parasitizing the caterpillars in the field for about 2 weeks. And we also conducted training sessions on how to produce these parasites. We conducted one in Nairobi, Kenya, and another one in Niger. Next slide, please. And altogether, we had about 40 candidates from 20 different countries trained in how to produce these parasites. Next one, please. What we are trying to do is in the IPM Innovation Lab, we try to collect these parasites locally and then use a center for producing these parasites in the laboratories. And then from there, we try to get, disperse the technique to the countries. So in the case of East Africa, we are trying in Ethiopia, Kenya, and Tanzania. And we also ask the countries to provide the laboratories and the technicians and laboratory supplies to produce these things. Then we develop these nucleus laboratories in each country. And eventually we plan to set up satellite laboratories to produce that in different parts of the country and release this parasite. Next one, please. Same model we are trying to introduce into Nepal as well as Bangladesh. Here, IPM Innovation Lab works with the government laboratory in the capital city mostly, and like Kathmandu in Nepal. And then from this nucleus center, we try to set up all these satellite centers using cooperatives or some of the government institutions or the universities just to produce and help releasing these parasites. Next one, please.
Looney, we just got a bit of a time issue, so if we can just speed up a little bit. Yes. Great, thank you.
Okay. Augmentative research, biological control, we are talking about this augmentative only in the biological control. Even release of the chemical pesticide periodically come under the augmentative release. Next one, please. Okay, this is the last slide. Here I kind of mention about the benefits of the augmentative release of the biological control, because here we help in developing the human and institutional capacity building in each country. So all the money that we spend in producing these parasites and predators, they stay within the country. Unlike in the case of pesticides, most of the pesticides are bought from outside, the developing countries, and most of the money goes out. But in this case, it stays within the country. That's all. Thank you very much, Ali.
Excellent. Thank you very much, Muni. And that was a great presentation with lots of information. And just remember, everyone, the slides will be shared and you will have a copy of the recording as well. Remember, if you have questions, please put them in the Q&A box, not the chat box. If you do have any technical difficulties, please just write it in the chat box there, and Pranav, our specialist, will help you out. We have some questions coming in now. We're going to have to do this quite fast, Muni, because we've run out a bit of time. But Muni will be able to actually go into the Q&A box afterwards and provide written answers to your questions. I've got a question here, Muni. How cost effective is telenomus as compared to the use of trichogramma for fall armyworm?
Telenomus rearing has some problems in the sense it has been used in South America quite widely, and now we are attempting to use it in Asia. Telenomus rearing in the laboratory would be done using the fall armyworm eggs, but there are reports that showing that it could be reared on the rice meal moth. So we are trying to standardize it. If we can rear it on the rice meal moth, it will be a lot cheaper. Trichogramma is always reared on the eggs of the Corsaira cephalonica, or the rice meal moth. So the cost effectiveness of telenomus is a little bit more expensive than trichogramma, but we are trying to reduce that, and hopefully we will be able to standardize that technique shortly.
Great, excellent, thank you. And I can see here I've made a mistake on the slide, and I think it's from the old slide from last week with Roma, but we definitely are asking Muni questions today. I have another question for you here from the Philippines, and it's something that I've also asked you in relation to running potential technical workshops for the ASEAN Action Plan. But dear Dr. Muni, do you have a plan to include the Philippines as a training venue for mass production of parasitoids?
My program doesn't operate in the Philippines because my program is funded by USAID. They are authorized only to work in Vietnam, Cambodia, Bangladesh, and Nepal within Asia. But right now we are communicating through webinars like this. So I can participate in webinars very easily because it doesn't involve much of expenses. Yeah.
Excellent, thank you very much. And just for everyone out there, I've actually asked in discussions with Dr. Muni about how we can take advantage of his knowledge and the work being done in the Vietnam and Philippines and bring that to the rest of Southeast Asia. Another question, you mentioned your sort of model that you're using in Nepal. Is that a model that you could use in other, in Southeast Asian countries?
Yes, definitely we can use that. The same model first we developed in East Africa, in Kenya and Tanzania. Now we are trying to, implement in Nepal. We had problem with because of the coronavirus. We were not able to move fast this year, and eventually we plan to come to Bangladesh. And in fact, we are also working in Cambodia with Rika on that. Excellent. So there is a question about whether telenomus only affect fall armyworm eggs or other armyworm. Actually, it attacks other armyworms like Spodoptera mauritius, Spodoptera exigua, Spodoptera litura. So it could be used for controlling other caterpillar pests.
Excellent, great. And that's just answered another question. You must have been reading my mind. I have another question here from Ravi Joshi in Philippines. Hi, Ravi. Dear Dr. Muni, why some species of trichogramma are more effective than other trichogramma species on fall armyworm? Is it related to the length of the ovipositor?
It's hard to say what exactly is the case. Like some species are specialized, some species of trichogramma are specialized on the eggs of some lepidopteran species. For example, in the case of rice stem borer, Trichogramma japonicum is more effective than other trichogramma. In the case of diamondback moth, Trichogramma bacteria is more effective than others. So we have to select which species of Trichogramma is more effective on these species. Like Trichogramma proteusum in South America, as well as in India, they are finding it to be more effective on fall army worm. In Tanzania, we found this Trichogramma wanjai also very effective on the Trichogramma, on the fall army worm.
Excellent. Well, thank you very much, Muni. There are some questions there for you. If you could answer them in writing on the Q&A, and then everyone will see the answers as well, that would be most appreciated. Just go into the Q&A box and you'll see quite a few there for you. Thank you so much for that presentation. We really appreciate you getting up in the morning, and I think it's 4:30 in the morning or something terrible like that, where you are based in Virginia in the US. So thank you so much. And we'll hopefully, you'll keep joining us through the length of the webinar.
Okay, thank
you, Muni. Thank you very much.
Bye.
Excellent. I'd now like to introduce our next speaker, Dr. Ted Turlings, who is a professor at the University of Neuchatel in Switzerland, and currently he's head of the Laboratory of Fundamental and Applied Research in Chemical Ecology, which focuses on the use of plant-produced signals to improve crop protection. In addition, he's also the director of the newly established Centre of Competence in Chemical Ecology at the University of Neuchatel. And Ted, can you hear me and join us, and welcome?
Yes, I hear you well. Thank you for that very kind introduction, and greetings from Switzerland. I will be talking about how our efforts to use nematodes against fall army worm, and this is a collaboration between the University of Neuchatel, CABI, and the Rwandan Agricultural Board. So the field trial that I'll talk to you about was done in Rwanda. Next slide. And we'll see here the two players in this. They're both the brains and the muscle behind the research that was conducted. Stefan Tupfer from CABI and Patrick Fallet from the University of Neuchatel, a PhD student who is also in the audience and who can answer some of your questions probably better than I can. Next slide. No need to explain to this audience that fall army worm has become an extremely important problem in Africa. And that's why we do our field trials for the moment, but I hope to extend that also to Asia. Next slide. In Africa, estimates from mainly CABI showing tremendous impacts on the production of maize and probably losses of up to $5 billion US dollars per year. Nematodes have a potential as biocontrol agents against many insects. They're usually considered against root pests below ground, but the observation that we made, and you can see that in the next slide, when we started looking at using this nematodes, next Alison, our first efforts were actually to try to use nematodes against the western corn rootworm, next, where we have not just the beetle being a problem, but mainly the larvae that feed on the roots. And we're considering to use nematodes in beads, as you will see in the next slide now. We were able to put nematodes in small alginate beads of about 0.5 centimeter in diameter, up to 5,000 nematodes that we put to sleep by adding a certain chemical to it. And when we add water, they wake up and they are able to infect those larvae in the soil. So we were considering to use this as something that it can be planted in the soil together with the seeds and then against the larvae. But we also were considering to add feeding stimulants and attractants to it. And while we were playing with that in the lab, as you will see in the next little movie, we were trying this without realizing how important fall army worm would be coming. If you can see, if you can get the video started, yeah. So here you see the small little beads. We add some coloring to it, so when they're blue. Here the nematodes are moving, but we can put them to sleep. And we were just playing with it, adding leaf extract to the beads, and we got fall army worm larvae that we are also working on at the time, feeding on it. And if there are nematodes in those beads, within a day or two, the larvae will look like this, completely dead. And they become then the source of a new generation of nematodes that eventually will burst out and can also kill the next generation of the pest. So that's what this video is showing. So this was already done before we started working on nematodes against fall armyworm. So that had great promise, and we got pretty excited about possible prospects of applying this in the field in Africa. Here you see Patrick with many curious people looking at what crazy things this Swiss guy is doing there. We were then decided to not use nematodes that we have in Switzerland, but actually go to Africa to see if there are any nematodes in the soil there, and that we can then apply effectively against fall armyworm, because we don't want to introduce new species or even new genotypes of the same species that may be occurring there. We want to use local nematodes, and if we get the opportunity to do that in Asia as well, we'll do the same thing, look for local nematodes against fall armyworm. Next, so initially, next slide, initially Patrick then designed a number of laboratory experiments. Within these cages he had maize plants with fall armyworm on them, and then applied different treatments, including the beet treatments, but eventually we switched to gel treatments. That's easier to apply, so the same material, alginate, but then as a gel applied to the center of the plants. Next slide. And then look at larvae that were on these plants and see how they survived. So here are the different types of treatments that he applied: just water, nothing in it, oil and gel without nematodes, and then to the right of each of these two bar graphs you see these formulations with nematodes, and you see that there's, in terms of caterpillar survival, the gel application with the nematodes was the most effective, killing 100% of the larvae that he applied in these cage situations. So this is not the field yet, huh? And then in terms of damage to the plants, you see that that's also very significantly reduced by applying these nematodes. I should mention that the oil application is a commercially available formulation that we used as a comparison to our gel. And you see that we're at least as good, the gel. Next slide. So then he went to Africa with Stefan and collaborated with the people from RAB in Rwanda. They selected 4 different fields to do this experiments. I'm going to show you the average for over all the fields. Patrick emphasized to me still yesterday to mention that these fields were very heavily infested by fall armyworm throughout the season, and therefore were ideal to test this. Here's Patrick putting the gel together in collaboration with the people there, including the nematodes. Next slide. This gel was then placed in these glue guns that can easily, relatively easily, squirt this gel into the center of the plants, as you will see in the next slide. In these, so here you see how the application is done, and at the same time other plants were treated with different treatments like the ones I showed you before: water with nematodes, oil with nematodes, as well as a pesticide that he used as a extreme control measure. Next. So here we'll see a few slides with the people applying here the gel, selected plants that were treated with the gel and nematodes, and others were treated differently. Next slide. Again, you see that that is a real team effort. Next, Alison. And here you see one of the successes. So Patrick smiling there because there were dead larvae, as you see there, and they definitely looked like they were infected by nematodes. Next slide. And that was confirmed. So here's the same picture with a close-up of the larvae that were dead. And when they took those to the lab, eventually, it's not a very good picture, the nematodes burst out. So they were definitely killed by the nematodes under the field conditions. Next. They then, in all of the different treatments that were used, they were used after 5 days. A certain number of plants were inspected for larval presence, and 10 days another group of plants, looking for the numbers of larvae that were present. They also looked at damage, but I won't show you those results today. And here is then the most critical slide of them all, with the raw results for after 5 days, using the control that was not treated with anything as the baseline. So the numbers of caterpillars found there, and then the reduction in the percentage of caterpillars on the other treatments. And you see the pesticide and the gel were about the same. Actually, the gel slightly better after 5 days. A reduction in 40% of the larvae. Let me remind you that it was very heavily infested here, because 40% may not be so impressive, but the pesticide didn't do any better, and they used a very high dose of pesticide. So better than the pesticide almost, and that was also at least as good as the pesticide statistically after 10 days. Oil, a commercial oil with nematodes and water with nematodes were not as effective. So that brings me almost to the end already of this presentation, to show you that this can be used in the field. This is what would happen if you don't treat the plants with anything. The larvae will eventually completely destroy the center of the plant. And in the next slide, you'll see that this is what you end up actually when you have gel treatments. The caterpillars will get killed long before they do that kind of damage. You see the old leaves have larval damage, but the center of the plant has survived this very nicely, and the plant can grow as it wishes and develop completely. A few simple conclusions. The nematodes have great potential to serve as biological control agents in fall armyworm. We recommend that we use weekly applications. This was only once, but the larvae certainly under those very heavy infestation conditions, circumstances will come back, also move from other plants in there. That was probably the explanation why we didn't see better results. The formulation can be further improved by adding attractants and feeding stimulants. And we will want to focus next also on making this as simple as possible, because we want to do this, use this technology for subsistence farmers, and that also applies for possible application in Africa. My last slide is to then thank again the people that did the actual work. So Stefan and Patrick, together with the staff of RAB, who did all this, and they will continue to do this to make it work even better than it already does. I thank them. One more click. And thank you for your attention. I will be happy to answer questions.
Great. Thank you very much, Ted. Can you hear me?
Yes, I do.
Oh, great. Excellent. So sorry. Look, that was a fantastic presentation. Great photos. And I really liked the video. It worked a bit faster for me than I think it did for you. And perfect. And I quite like this idea of putting the nematodes to sleep. It was nice that you could wake them up again, I thought. But look, do you think there are local nematodes in Southeast Asia that a similar project could be developed?
Yeah, there must be plenty of species present there, and the species that we are working with are considered to be globally present. There's still some discussion about the taxonomy, so whatever defines as a species is a little bit up in the air still. So we would like to get, even if it is the same species as we may have in Europe, I would like to get the one from Southeast Asia if we want to apply it there. In order not to introduce any different genotypes that are not natively present. But definitely we will find nematodes that could be effective against fall armyworm also in Asia.
Great, thank you. Here's a question. Has weather, or does weather have any effect on EPN efficacy on fall armyworm? So does the weather play a role?
Yes, they are definitely sensitive to UV light, and drought will be a problem. Under the conditions that they were applied in Rwanda, it was during the rainy season, so there was quite a bit of water, and that is, in a way, is good. That also will, in the case we put them to sleep, that will wake them up because the compound will be diluted. That puts them to sleep. But yes, in this gel, we also plan to put some sunscreen, if you wish, to protect them better against the UV light, but already placing them in the world of the maize plants will protect them against UV. And as you see from the results, they did manage to survive and kill these larvae. They survive for several days, but the weather conditions will have an effect, yes.
Okay, just looking at, I know that you took some time in thinking about how to apply these nematodes with the gun, which looked very easy and quite simple but innovative. For large scale application of gel-based application, is that viable, do you think?
It depends on what kind of farmer you're talking about, but the farmers that we're working with right now, I think for them it would be very easy to do it the way we do it. So they have relatively small farms. They already are willing to go out in the field and kill the larvae by hand. So it's a lot less work to apply the gel. We're still working on different types of formulations that are easier to apply, and also with larger squirt guns that we can apply. But if it's a weekly application as we have foreseen now, just manually by the local farmers, I think this is definitely something that would be.
And so economically, have you done some economic analysis comparing it to other methods?
No, we haven't done exact analysis, but I would say that rearing the nematodes would be at least as cheap as, say, the mass rearing of trichogrammas, and would be less effort. I could imagine that we would have small startup family companies that we could teach to do this. We're far from that, so I'm giving a very optimistic scenario. But what I think nematodes are, if we develop the right technology locally, are relatively cheap to produce. The alginate is nothing expensive, and we can probably make that even cheaper. So I'm quite optimistic that in terms of biocontrol, this would be one of the cheapest solutions to use.
Excellent. And just one question: how do those guns? How good? I mean, they're obviously quite simple to use, and anyone can use them in the field. Did you get some feedback from farmers on how they perceived the use of nematodes and how they perceived the method that you've developed?
I think we'll probably let Patrick answer that in the chat, because I'm not, I think they must have talked to some farmers, but it was mostly the local researchers that they worked with. So I cannot give you the real answer to that. What I understand of the difficulty is actually to get the gel into the squirt gun. It's a bit of a messy work. So we're now looking at a different kind of formulation that is easier to introduce into
okay.
that.
And I've got one more question that's sort of related actually to what I've just asked, but it's in the same question. In which instar level is the gel and nematodes the most effective? Is that something you can answer?
Yeah, there were laboratory studies, and they've also done here by Patrick and a master student. As far as I remember, all the larval instars get killed.
Okay. And one more question, because we have to move on to our next speaker, but we've got lots there, so you and Patrick are going to be busy, Ted. Do these nematodes have a positive symbiosis in case of roots or negative symbiosis?
A symbiosis with the roots, is that the question?
I think so. Okay.
So these nematodes do not attack the plants. So these are definitely different from Phytophagous nematodes. And what we actually have, and this is coincidental, but what we have discovered is actually when in their presence, the roots will respond molecularly, and actually the plants will defend themselves more strongly, and induces some more resistance in the plant. Completely different topic, but it's definitely an interesting additional benefit that we think we will have by.
Well, that certainly is an interesting additional benefit, and that's probably a good place to leave it for now. There's lots of questions coming in for you and Patrick, so feel free to get on the Q&A and answer some of those. And thank you very much, Ted, for joining us, and thank you for Patrick too, and some great photos of seeing you out there in the field too. That's very nice to see. So thank you very much, Ted, Patrick.
Thank you.
And you can turn your video off now, Ted, and I'd like to introduce Dr. Zhenying Wang from the Institute of Plant Protection in the Chinese Academy of Agricultural Sciences, and he has worked on IPM of corn insects for more than 30 years, and his work has involved IPM of fall armyworm since 2019 when it invaded China. He is also a member of the FAO Global Action Fall Armyworm Technical Committee. So welcome.
Thank you for kind introduction. I'm introduced mainly as a biological control. Yeah, you know, the fall armyworm just arrived in China last year. So first, we survey and identification of natural enemies of fall armyworm in China, and also we did a lot of measuring and also some experiment release for fall armyworm control. Please next. We already, yeah, next, please. We already found 2 egg parasitoids. Is also like Dr. Mini mentioned, the Telenomus remus and Trigorama calynis. These 2 species had a natural, the high natural parasitization rate. Next, please. And also we found 5 larval parasitoids. This one, Macroplatis, and also Cortesia. Next, please. And also another 3, and also is Malacrosis similis and Eclopcautius and Diadigramma. So these 5 larval parasitoids we already found in south part of China. Next, please. We also found 1 pupal parasitoid and also 1 egg larval parasitoid. Next, please. In the field, we found many predatory bugs. We found 4 kind of the bugs like the Amiatrinicis and also Pagromerus levici. These 2 species, in my institute, some professors did the function response in the laboratory. The nephews and also the adult, they can predict a lot of the larvae of fall armyworm daily. Next, please. And also another 2 predatory bugs we also often found in the field, and also they can predict a lot of the larvae of the fall armyworm when they did the experiment in the laboratory. Next, please. And also, we found a lot of the lead-blood beetles and also the lesbians in the field. They can predict the egg masses of the fall armyworm and also the larvae or different indices of the fall armyworm in the field. Next, please. We also found 1 predatory columbid beetle. The adult and the larvae also can predict the fall armyworm larvae in the field. Next, please. We also found 1 earwig. The adult and also nephew, they can predict the larvae of the fall armyworm in the field and it very effectively. Next, please. You know, for the Trigorama mass-rearing is a long history in China, so we have did some of the rearing techniques very successfully. Next, please. We rear the Trigorama in China. We use 2 methods. Either small egg masses, small eggs for some species of Trigorama, and also we use Chinese oak silkworm for other several species. Because the Trigorama calynis, it can be read on the racemose eggs. So this is the mass-rearing for the Trigorama or the calynis and also other species. So this is the mass-rearing for the racemose larvae, and this collect the racemose adult. Then the machine for collect the eggs of the rat moth, and also they clean the flat egg because they have some skill on it, then make the egg cut, then really introduce the trigramma, is prepare the parasitoid egg cut. Next, please. And also, we use the cystrog eggs for measuring the trigramma. This method is introduced from Europe, but developed in China. So this is a production line for measuring all the cystrog eggs. So this rearing cystrog eggs, this collection of the moth, then collect the eggs of cystrog, then for trigramma measuring. Next, please. And also, in the laboratory, we select the candidates for rearing the telenomous lemurs. We found the Cispotera latura, the egg method is very good candidates for mass rearing of the telenomous in the laboratory. Next, please. And also a pilot production for the predatory bugs very successfully in the laboratory by using artificial diet. This one is species Amera chinensis. This one is already mass-produced. It's partly used for the cash crop like tobacco to control some of the Lepidopteran insects. Next, please. And also a pilot production, another predatory bugs, and in large scale, and also they have products then released in the field. Next, please. Next, please. Yeah, the field release for the fall army control. Next, please. A pilot release to control the fall army by release the telenomous lemurs. We release the parasitoids, and also we harm some the fall arm eggs is a laboratory produced, then release the parasitoids. After 3 days later, we take back all the fall arm eggs, then check the parasitoid rate of the fall arm eggs. We found the telenomous lemurs has very good control effects on the fall arm eggs. For the egg methods, the parasitoid rate is 100%. For the eggs, is over 80% of the eggs is parasitized by the telenomous. Next, please. Trigramma colonies is also released to control the fall arm in the field. After release, we found the parasitation rate for the egg methods and the eggs of the fall arm is 70%, over 70% and 80% respectively. Next, please. And also, in some laboratory, did some experiment to release the predatory bugs. So when they release the different ratio of the predatory bugs, this species, Rangaswamy, when at the different ratio 1 to 20 and 12 to 110, they found after 2 weeks the release fall arm larvae is predated by the predatory bugs. So the compared with the pesticides, when the 1:15 ratio, 100 release the forearm larvae is predated by the predatory bugs. Next, please. And also, they release another predatory bugs, Amartenesis. They release the adult and all nephews, and they found when at the density of 450 adult per hectare, after 7 days later, nearly 76% of the control effect achieved when released the density of 600 nephew per hectare 7 days late. So they got very good control effects. And also some of the experiments did by releasing another predatory bugs. They released the auris for the forearm control. When they release at the density of 20 for a corn plant, the control effects are over 30% in the kid test. So this is the result. So because only 1 year's experiment on the forearm release for the biological control, so that's the mainly result by the natural enemies for forearm control in China. Next, please. Oh, it's thanks for some professor provide some of the data and the photos. Next, thank you for attendance.
Thank you so much. That was incredibly interesting, and I'm just struck by the amount of examples that you had there, and how many possible candidates for natural enemies that you actually identified. It seems a very extensive program. Just, I guess one question would be here is how economic, like, is this an economically feasible approach do you think, for countries to be investing in and for farmers to be using?
Yeah, for the, for the trichogramma in China, we use it for the control the Asian corn borer for many years. So this especially when release the trichogramma, use the big hook, the Chinese oak silkworm eggs is very, very cheap per hectare. I think is around per hectare around $3 to $5. But if you use the small eggs like the red moth egg or citron eggs, it's a little more expensive compared to the Chinese oak worm eggs. But it's also 1 hectare for one release is around $50. But because the technique is very mature in China, because the different kind of egg cuts, and also even now we release the trichogramma by the drone. So I think for the trichogramma release for control the forearm in the south part for the overwinter for the year-round occurrence areas, for consecutively release, it will keep the forearm worm at a low density. I think it's
excellent. And you use drone to release it.
Yes. No.
That's interesting. A question here from Ravinda Joshi again. Good to see your questions coming in. A lot of interest here. Have you encountered any parasitoids during natural enemy surveys?
Pardon?
Have you encountered any hyperparasitoids during natural enemy surveys?
One doctor already found in Guizhou province, they found 3 hyperparasitoids wasp already, 3 species.
Excellent, thank you. A question here. It says, well, it also says, thank you for the many examples you provided. Can we use the earwigs that are commonly found in banana in controlling armyworm? Is there a specific type of earwig that works better, or do you think any earwig offers some opportunity here?
Earwig, earwig is, I think first we can protect in it if we plant the corn intercropping with other crops, provides the high the different biodiversity. This one can protect it, and also in China, in some laboratories, they began rearing the earwig and release, and also have some result release in the field to control the fall armyworm already.
Okay.
In China, yeah.
Dr. Wang, which is the most or the more effective fall armyworm predator, the pentatomid or the reduvid one?
The predators, because mainly they found it's very effective in the field, so many predators now in laboratory they use the function response to that, and amaranth predator bugs. These the adults, when they can predict the third instar larvae, they can over 60. So they release it in the small scale field. They have very good control effect.
Excellent. Thank you for that answer. I have another question here, and then we may allow you to answer some of those questions in writing, because there's quite a few coming through. Question here: on which host do you rear Arma chinensis or chinensis as a predator?
At first, they use some the very easy red host, like the oriental armyworm, because it can easily mass rearing. But now in China, they already developed one artificial diet, uses some of the insect ingredients, like the silkworm eggs, silkworm moss, pupae. But still a little bit expensive, but not. If they want to reduce the cost for mass rearing that.
Yeah, excellent. Thank you so much, Dr. Wang. I would just have to say that there's so much information that we would like to ask you, and we'll definitely welcome you back and all the other speakers today. It would be great to work more closely, because obviously there's a lot of work that all of you are undertaking, and in China there seems to be a particularly huge efforts going into managing fall armyworms. So it's great to see, and thank you for sharing that with us today.
Thank you.
Thank you, Dr. Wang. And if you could answer any questions on the Q&A box, that would be most, we would be most grateful. Thank you very much.
Thank you.
I'd now like to introduce our last speaker today, Chris Wykas, and I'm not sure I did pronounce that, and I promised I would try much better this time. Chris, if you can turn on your video, or you can keep your video off actually, and we'll just turn it off in the Q&A if that's better. Chris is a Belgian bioscience engineer and insect ecologist, and Chris lives in Vietnam and works as an independent consultant, and is very experienced in devising and validating nature-based solutions to pest control in both temperate and tropical settings. It's a pleasure to welcome you, Chris. Chris has guided me through with lots of advice and expertise over the last 6 months, and it's truly a pleasure to have you as the last speaker of this biocontrol webinar series. Chris.
Yep. Thank you, Alison. Thank you for the invitation and the introduction. So I have a short, broad picture presentation. So not really a technical presentation, but more a broad picture presentation. And I will start with a color. I start with the color green, my favorite color. Next slide, please. So green is the color of the world when we observe it from space. Admittedly, the oceans are blue, but most of the terrestrial landmass is green. Next slide. And the world is green because the action of herbivores, such as this colorful caterpillar here, is kept at bay. Herbivore action is kept in check by a whole range of organisms. Next slide, please. Belonging to different life forms and animal taxa. These formidable allies are indeed the little things that run the world, as E.O. Wilson says, and their pest control action is worth billions of dollars. Next slide. Yeah. Evidently, these so-called natural enemies should be farmers' friends. They work 24/7, night and day, rain and shine, without drawing any salary. What conservation biological control really pursues is to conserve farmers' friends, is to protect them from harm, to sustain their field populations, and to boost their biological control services. Two golden principles and one truth underpin conservation biological control. Next slide. Yeah. Principle number one, what one kills, one cannot protect. Principle number two, what one protects, one shouldn't kill. And truth number one is dead bugs do not provide pest control. So these two principles and this one truth, they really embody what biological control, what conservation biological control is all about. That we have to conserve, we have to protect farmers' friends, we have to protect those six-footed allies of farmers across the globe. Next slide. So I may have been stating the obvious with those two principles and one truth. These golden principles are not well understood, nor by farmers, nor by government decision makers. Indeed, the dominant form of crop protection across the globe involves the repeated use of pesticides in farmers' fields. And the golden principles of biological control are violated every single day, be it one, through the preventative use of systemic insecticides at the time of planting, be it through insecticide-coated seeds and pesticide dips. Two, by blanket applications of synthetic pesticides, including with drones. And three, by the use of broad-spectrum products which kill pests and natural enemies alike. Next slide. Yeah. Instead, what one should pursue is IPM. IPM, or Integrated Pest Management. IPM entails the tactical integration and deliberate prioritization of pest management practices, in which preventative approaches, such as biological control, really constitute the first line of defense. They make up the bottom of the IPM pyramid. And then curative measures, especially the use of synthetic pesticides, they are a measure of last resort, used wisely, sparingly, and in a targeted fashion. Always keeping in mind that pesticides are toxins, products meant to kill. Next slide. Cutting pesticide use is thus essential in order to effectively promote biological control, and especially conservation biological control. Though I hear people in the audience already whisper that cutting pesticide use is impossible. Such was entirely feasible 25 years ago. Through the UN-backed Farmer Field School program, millions of farmers across Southeast Asia, across the entire Asia-Pacific region, were trained on biological control, were trained on non-chemical crop protection, and pesticide use as a result was cut by up to 82% in rice, by up to 50 to 70% in tea and cabbage, and from 1992 to 1997, when I was still a teenager, training programs decreased insecticide use by 50% without any loss of crop yield on 2 million rice farms throughout the Mekong Delta. By doing so, biological control was given a chance. Next slide. Now, specifically for fall armyworm, there is a long lineup of natural enemies. As we already heard in the previous talks by Ted, by Zhenying, by Muni, ants, earwigs, entomopathogenic nematodes, and parasitic wasps all act against Spodoptera frugiperda, hitting fall armyworm hard across its invaded range as well as in its native range, causing parasitism levels regularly up to 90% and resulting in a pupil predation often up to 90% or higher as well. Next slide. So now those natural enemies, there are different ways to encourage those natural enemies in a farmer's field. A first approach is by providing shelter for farmers' allies. Shelter can be provided through the establishment of beetle banks, which are small strips of unplowed land in the center of cropping fields where natural enemies such as ground beetles or parasitic wasps can take shelter. Next, mulching can be done of farmer fields. Next one. Next, zero and conservation tillage. Next, the establishment of inter or cover crops with beans, with mung bean, with soybean, with groundnut. Next, by the deployment of bird boxes or bird perches. Next. And then for natural enemies that work the night shift, Cambodian rice farmers have devised ingenious contraptions to shelter their populations from harm. So bats during the daytime, they can roost in these structures that are built by Cambodian rice farmers. Next. Nectar and pollen are the high octane fuel for many of these natural enemies. Farmers can provide these vital food sources by establishing flower strips at the field border or by making occasional applications of sugar water sprays, as has been tested extensively in Central America as well as in parts of Africa. For millennia, Vietnamese and Chinese mango and citrus growers have benefited from the pest control action of the weaver ant Oikophila smaragdina. They sustain ant populations in their orchard by feeding them with kitchen scraps and chicken bones. On the other hand, Indonesian rice growers add organic matter to their fields, which enhances the population of plankton feeders and detritivores such as this red chironomid larva, and thereby they support biological control. Both of these groups of farmers routinely do not need any pesticides for pest control. Now, does it really make a difference? Of course it does. Nicaraguan cabbage growers who refrain from pesticide use and who employ conservation biological control earn a staggering $2,200 more than conventional growers. In Benin, cotton growers that rely upon biological control pocket more than $250 more per hectare than conventional farmers. And in Indonesia, cacao growers that actively protect insect-killing birds and bats earn $730 per hectare. In all these systems, farmer income soars, the rural economy thrives, and nature benefits. And in the end, isn't that what we all pursue?
Thank you very much, Chris. That was a very, I was going to say picturesque, but serious at the same time presentation. So thank you very much for that and for all the examples as well. I'm just going to check the questions that are coming through. So I'm sure there's lots as well. I've got a question for you here, and it is, how easy is it to maintain this type of approach in the face of a rapidly changing conditions, for example? So is it easy to do this for farmers when you have a huge infestation of fall armyworm coming your way?
Oh, I think it's easy if you reduce the dependency on pesticides and you build in diversity in the system. You respect soil health, for example. You maintain natural elements in the agricultural landscape. You give biological control all possible chances to act against fall armyworm, and maybe the level of biological control will be low in year one, but steadily it will build up as long as you remove the unnecessary disturbances in the system, and you make sure that shelter, alternative host and prey items, pollen and nectar and diversity are provided. I think it will work in the end.
And how long does it take for the yield to be the same or more? I mean, you gave some examples where yield was higher, but when you're starting out on this approach, perhaps, or changing from another approach, how long does it take until your yields increase? And I'm just thinking of smallholder farmers that don't always have a lot of cash at hand to invest or to change farming practices. How long does it take, do you think, before they can see the return on their investment?
Yeah, I think it all depends on the farmer context. If you are in a heavily intensified farming setting in which soil health is very low, in which you've been using pesticides and chemical fertilizer for decades, it'll take time for diversity to increase, and it'll take time for biological control services to be back up to normal or optimum levels. So that may take time. But if you're a smallholder farmer cultivating half a hectare in a very diverse environment, with the field surrounded by a range of different habitats, including crop and non-crop habitats, or maybe after less than one year, your yields will be just the same as in a setting in which you would use other chemically derived approaches.
Okay. I have a question here. Any effort to implement your hypothesis or this approach to manage fall armyworm? I mean, are there examples of this for fall armyworm in Southeast Asia now?
In Southeast Asia now, conservation biological control,
Yes.
I imagine in different countries, certain aspects of conservation biological control are being tested. Agroecological techniques such as intercropping, cover cropping, I am sure that is being tested in different Southeast Asian countries. approaches such as beetle banks, flower strips. I think that is being evaluated in China and maybe in some other countries as well.
Okay.
Yeah.
Here is a question here. I have use of insecticides is obviously a disturbance that adversely affects natural enemies. The challenge is, however, how do you convince farmers not to make unnecessary insecticide applications?
Yeah, I think that's really the challenge. We have some publications over the past two years that have shown globally how farmers are basically unaware of all those allies that they have in the field. They don't know the natural enemies. They don't believe in biological control, and they do believe in pesticide-based approaches. So the bottom line here is really to train farmers, to raise farmer awareness about those natural enemies, about ways to protect them, and about how to steer clear of pesticide use. Because for many farmers, the use of pesticides is insurance. Basically, it's a risk-averse approach, and the more they apply pesticides, the more they think they safeguard their yield from eventual upsets and disturbances such as fall army worm pest outbreaks.
Okay. On the top of that pyramid, I mean, you did see in that IPM pyramid, there was the efficacious use of pesticides. When is that? When do you think people can use that? I mean, when does that come into play?
Oh, so the use of synthetic pesticides is really a measure of last resort. When nothing else works, then a farmer can take the pesticide bottle and spray his or her field. But there's many other approaches that should be given priority. When does a farmer need to apply pesticides? Well, there are decision criteria under IPM, such as an economic threshold or economic injury level and an action threshold. So there are certain infestation levels under which the use of synthetic pesticides is economically justified.
Okay.
In 30 to 40 day old cornfields, this could be at an infestation level of 20 to 30 larvae per 100 plants.
Okay.
So these infestation levels, they are not zero, but they are not exceptionally high either.
Okay, Chris, I've just got one other question here as well, which I want to ask you, because we have to draw a close. If you could answer this very quickly, what other predators observed when using leguminous crops as shelter in the field? Thank you.
Say it again. What
other predators have you observed when using leguminous crops as shelter in the field?
Oh, the ones that occur within a system, several of those will increase in abundance in a diversified farm, in a diversified maize field. So this could be an increase in abundance of ants. It could be an increase in abundance of ground beetles. It could also be of parasitic wasps, because many leguminous crops, they provide extra floral nectar and floral nectar to foraging parasitoids. So many of the good insects, many of the natural enemies will increase in abundance and will increase in pest control action against fall army worm as well. It is not just one, it is several.
Great. Well, thank you very much. And there's a few questions for you to answer as well. If you could just jump on the Q&A while we close, that would be appreciated. I'll give you a little bit of time, hopefully, to answer those. There's a good couple of questions that have just come up, Chris. So thank you so much for your presentation. It was a pleasure to have you end the session. And I'd now like to introduce Dr. Rika Floor from IRI, just to give a few summary comments. We may just finish 2 minutes late, everyone, so I hope you can stay with us. Rika?
Yes, Alison, thank you so much. And I just so tremendous knowledge that was provided by the speakers today. Really, the experts in the field have shown us a wide range of biological control options for fall armyworm, that in each country there is not a lack of these from egg parasitoids, larval parasitoids. We've heard about insect killing nematodes. There are many types of predators, even hyperparasitoids that are out there. And we've also been taken through how these are mass-reared kind of diets that are being prepared, and how these are released into the farms. Indeed, there's a bit of discussion also on how to make these kind of systems work for getting biological control out to the farmers, the type of institutional arrangements that are necessary to bring this, whether it is about smallholder farmers working on their own, or whether it is about a system of institutions and laboratories bringing out biological control and releasing it, providing mass release for the farmers. So these are kind of different ways in which institutionally biological control and release can be done for the farmers. Chris also brought it back towards the importance of conservation and how these types of biological control, they exist a lot. They provide such good service to the farmers, to the world in general, and they are not compatible with the current practice of reliance on pesticides, and how important it is to have this integrated pest management practices and practices that will conserve the natural enemies that already exist in the environment. So with that, I think we have a real treat of learning from these experts today. Thank you very much to all our speakers and to CABI and Grow Asia for organizing this.
Thank you very much, Rika. That was an excellent summary, perfect. And I agree with you. It was just a real treat of information and speakers sharing what they're doing. I mean, it's a great way to end the series. And I just want to say to everyone that it is the last of the series, but we are looking at some technical workshop sessions for November to sort of carry on the momentum and to talk about some of the more technical questions and ways to do these things. And that's certainly what the ASEAN Action Plan is wanting to do as well, is to look at those institutional type questions and how we can work together regionally better to get some of these things out there and into the hands of farmers. So we will be in touch. Before we leave, I'd just like to thank everyone at the ASEAN Action Plan, Grow Asia, particularly Graham and Pranav, for helping make this webinar a success, as well as our supporters and donors. And Grow Asia would very much like to thank CABI for your collaboration on this series. It was great to be working with you and to continue working with you in the future on this focus on biocontrol. It's always a pleasure to work with you, Roger and team. A huge thank you to all the speakers across the entire webinar series over the last 6 weeks, and particularly to those ones today. Just thank you again. And to all of you who are listening online, it's fantastic that so many people have taken part. We've had over 1,100 people register. It's probably up to 2,000 now, so thank you. And I'd like to call this series to an end for October. Take a rest until November, when we'll be back in contact. Until then, take care, everyone. Bye.